Hi, this is Miss Wetland here to talk about the properties of addition and multiplication. How many of you like to do things the easier way? Well, these properties that we're going to look at today are rules that allow us to rewrite expressions. So if you can have your note packet out and be filling it in with me, that would be great. They allow you to rewrite expressions in an equivalent way. And usually that way is making it an easier problem for you to solve. So as we rewrite these problems, we're really saying that equals can also be said as can be rewritten as. So when we look at these properties, we're looking at different ways we can rewrite problems, sometimes to make them easier for us to solve and complete. The first property that we're going to talk about is the commutative property, spelled C-O-M-M-U-T-A-T-I-V-E. Commutative property. And you're going to notice that we put this commutative property in a bus. Because do you know what commute means to do? Has to deal with a bus or a car. Maybe your parents do this to and from work. What commute means to do is it means to travel or move. And in the commutative property, that's essentially what is happening. In the commutative property, it is the numbers that travel or move. So commutative property, the numbers, and the key word is there, it's the numbers that travel or move. Now, what does that look like? Well, they have a couple of examples for us down below. So if we go down and look at the examples, what the commutative property does is it tells us that if we have 7 plus 6, that really can be the same as 6 plus 7. Equivalent can be rewritten as. Now, if multiplication, the same is true. If I take f, or really let's just say I even took the number 2 times 144, I would get the same answer as if I just flipped the numbers around and did 144 times 2, or in this case, 144 times f. I'm going to get exactly the same answer, even if I rewrite it with the numbers traveling or moving. Now, sometimes when you're doing this, it will get specific on what operation is the commutative property applying to. Because the commutative property only works for two operations, and that is addition and multiplication. So sometimes they might refer to something as the commutative property of addition. That just means you're adding two numbers like a plus b, and you're going to get the same thing if you flip it around and do b plus a. So if numbers are flipping around and you are adding, they call it the commutative property of addition. Whereas if you are multiplying two numbers, a times b, you're going to get the same answer as if you do b times a. They call that the commutative property of multiplication. So sometimes you might see these words tagged on to the commutative property, and that's just identifying the operation that is occurring in them. So commutative property means to travel. In the commutative property, the numbers travel. Right? If we go on to the next one, the next property that we are going to talk about is called the associative property. And you're going to see with this associative property, we have two figures here, or two peoples, but we also have a handshake. Because do you know what associate means? Associate means to like work together. I often may associate with my coworkers at work. Usually you're in a group. So associate means to work together within a group. Now when I say group, and we think in terms of math, when you hear that word group or grouping, what comes to mind? What should come to mind when you hear that would be grouping symbols. So if we think about what are the grouping symbols that we have been talking about in order of operations, those would be like your parentheses and brackets. So associate means who we work together with within a group. Grouping symbols in math are parentheses. So the associative property relates to parentheses. And really what it's telling you is that, again, in adding or multiplying, it doesn't matter how the numbers group together. So for example, I could have 4 plus 2, which is 6, plus 6, and I'm going to get 12. Now, if I chose to group together instead of grouping the 4 and 2, let's say I move the parentheses. So I'm going to keep the numbers exactly the same. They are not changing. But instead, I'm going to change my grouping symbols to be around the 2 and the 6. Do I still get the same answer? Well, 2 plus 6 is 8, and 8 plus 4 is 12. So yep, in both cases, I got an answer of 12. We sometimes just might want to group problems in order to make problems easier to solve. And that works with addition, as we saw here. But it also works with multiplication. For example, if I gave you the problem 7 times 4, well, 7 times 4 is 28, and I asked you to multiply it by 25. Could you tell me what 28 times 25 is? If you're like me, I'm reaching for a calculator. I'm trying to think, okay, what's 28 times 25? Well, it's 700. Well, what if we grouped it differently? What if we kept the numbers in the same order, but this time we changed the grouping so that it was around the 4 and the 25? Well, what's 4 times 25? What's 4 quarters? 100. And what's 100 times 7? 700. Do you see how changing the grouping of the numbers made the problem a lot easier for us to solve? That's the associative property, and that works for addition and multiplication. And like the commutative property, they may name it sometimes with the operation that it's using. So the associative property of addition and the associative property of multiplication. So if we look at one more example down below, here they group together the 8 in G and then times it by 4. We're going to get the same answer as if we group together the G times 4 and then multiply it times 8. Or if we had the numbers 12 plus 3 grouped together, we could group the 6 and 12 together and we're going to get exactly the same answer. Sometimes we're going to want to change the group just to make an easier problem to solve. The associative property says that's okay. Right? Questions on that? Right. The last two properties, you know what this is here? That's supposed to be a mirror. When you look in a mirror, what do you see? You see yourself or you see your identity. So the next two properties that we're going to talk about are the identity properties. And like the other two, these identity properties are broken up into one for addition and one for multiplication. What is identity? Remember that identity is who you are. Okay? It's your reflection. It's the same. So with the identity property, we want to think about what doesn't change who the number is or what the number is in a problem. So when we look at the identity property of addition, think about what can you add to a number that isn't going to change its identity? It isn't going to change who it is. If you said 0, you'd be correct. So basically the identity property of addition just says if you add 0 to a number, you're not going to change its identity. You're not going to change that number itself. Now in the case of the identity property of multiplication, that one is saying What can I multiply a number by that isn't going to change its identity? Isn't going to change who that number is. If you said the number 1, you would be correct. When I multiply by 1, I'm not changing the identity or the value of the number. Those are two identity properties that you may see along the way in math. So if we go down to the examples at the bottom, this first one would be an example of what? This would be the identity property of addition, which basically says if we take a number or a variable and we add 0 to it, we're still going to get that same number or variable. Whereas the last example is going to be an example of the identity property of multiplication. Because in this one, we're now multiplying, and we're going to see that we're multiplying by 1, and multiplying by 1 isn't going to change the identity of the number or the variable. Right? Those are the different properties that we're going to explore in 7th grade here. If you have any questions, please be sure to let your teacher know. Thanks. Have a great day.